In our last session, we discussed classification of matter. Today, we're going to be talking about physical and chemical properties and changes. So, physical properties are properties that are detected by the senses or can be identified without a chemical reaction. Examples of physical properties include color. So, what color is something? Smell. What does it smell like? Texture. What does it feel like? Density, which is the mass per unit of volume. Electrical conductivity. Does it conduct electrical energy? Does it conduct electricity? Melting point. At what temperature does the substance melt? And then boiling point. When does the substance begin to boil? All of these are examples of physical properties. Chemical properties are things that refer to the ability of a substance to form a new substance. So those would be things like the ability to burn, the ability to decompose when heated or aged, or the ability to react with another substance. Examples of that could be paper burning, rust forming, or bread molding. A quick check for understanding. Take 3 minutes to answer whether or not you believe each of the following is a physical or chemical property. Your time begins. A quick check for understanding. Take 3 minutes to write down in your notes whether or not you believe each of these is a physical or chemical property. All right, that's our time. So let's discuss. Is acid reacting with a metal a physical or chemical property? Great responses. I would define acid reacting with a metal as a chemical property. Is silver turning green a chemical or physical property? We call this tarnishing, and I would describe that as a chemical property because a chemical property affects the substances involved in the change. Is the length of a metal object physical or chemical? I would say that the physical length of an object is a physical property. What about the color of milk? I would define the color of milk as a physical property. What about the freezing point of water? Baking bread would be a chemical property because we combine lots of different things to create an entirely new substance. Let's keep it moving. So, properties of substances may be used to identify and distinguish one substance from other substances. As we discussed previously, there are two types of changes: physical property changes and chemical property. So, now that we've talked about what physical and chemical properties are, let's talk about how we use those to identify things. Properties of substances may be used to identify and distinguish one substance from other substances. Within that, there are two types of changes. The first type is physical property change, and the second is chemical property change. So, physical change. This is a change that results in the substance itself staying always the same. The change can be reversed. An example of this is cutting a piece of paper. You can cut a piece of paper in half, and both halves of the paper will still be paper. And if you'd like to, you can recombine the cut paper by taping, by stapling, or even by gluing. The change can be reversed. A chemical change is something that results in a completely new substance. That change cannot be undone. So if I burn paper, I have ruined the ability for me to ever recreate this exact same piece of paper, and I've created ash from the burning remnants of the paper. So physical change can be reversed and the beginning substance stays the same. Chemical change cannot be undone. The beginning substance turns into something else. More on physical changes. During a physical change, the substance or object changes without becoming a new substance. So you start and you end with the exact same substance, and it can be undone. An example, we just talked about cutting paper, freezing water. Water turning into ice is still water. Melting ice, that's just ice turning into water. All of these things are the same. The substance itself has not turned into anything new, it's just taken a different shape. Molecules in physical changes tend to do this. We spoke about this earlier when we were discussing classification of matter. You start with a solid, the molecules are tightly packed together. You add heat, the molecules loosen up a little bit, it becomes a liquid. You add heat again, the molecules separate even further, becoming a gas. So, how do you know there's been a physical change? Three key, very easy things: a change in size, a change in shape, or a change in texture, the way something feels. Butter melting changes the size, the shape, and the texture of an item. Chopping or cutting wood will change the size and the shape, and the interior of the wood is now exposed, and that does change the texture of the wood just a bit. During a chemical change, however, a substance or an object changes and becomes a new substance by rearranging the atoms. You start and end the process with different substances. This is usually irreversible, which means you can't change the substance back. Examples of this include burning, rusting, and milk going sour. So, how do we know there's been a chemical change? There might be a change in temperature, as you see here. When you add baking soda to vinegar, the temperature will usually drop. The evolution of a gas, like a fizzy or foamy substance, think Alka Seltzer when you add it to water, like this. The formation of a precipitate or a powder, another substance, usually a solid, forming in the bottom of a liquid, is a precipitate. A change in smell, rotten fruit will typically begin to smell a little bit gross if you just leave it on your counter. A change in color. As leaves decay, we see that they go from their bright, vibrant green to yellows to oranges or reds to browns, or light given off. Fireworks exploding is a chemical reaction that creates the pretty lights that we see on the 4th of July and other holidays. So, quick review. Is baking a cake a chemical or physical reaction? What about fireworks exploding? Chemical or physical? Ice melting, mercury thiocyanate decomposing, tearing paper, boiling water. Popping popcorn, physical or chemical? Another check for understanding. In your notes, indicate whether this is a physical or chemical change. Another check for understanding. Indicate in your notes whether these are physical or chemical changes. You'll have 5 minutes starting now. That is time. So let's go ahead and review our answers. Trimming a bush because it has grown too tall. You should have gotten that that is a physical change. A sugar cube dissolves in water. This one was maybe a bit tricky. You should have gotten that that is a physical change. A chemical change produces new chemical products. That doesn't happen with sugar and water. The sugar and the water both stay the same as they were at the start. So that's just a physical change. What about you leaving your bicycle out in the rain and it begins to rust? I would I would call that a physical change. Burning coal for a barbecue. I would call that a chemical change. Molding a piece of clay into the shape that you want. I would consider that a physical change. And pouring milk on cereal. Again, I would consider that a physical change because the components of the milk and the cereal have stayed the same. Now you're going to complete the chemical and physical changes virtual lab as well as the lab sheet. You can use the link under Unit 1, Lesson 3, Evaluate Virtual Lab in Canvas to complete that.